Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. So we continue our lesson today with subtopic 4.2.2 changes in the right hand side. Okay, so there are three things that you need to find when there is a change in the right hand side. The first one is dual price for each of the constraint. Second one is feasibility condition. And then the last one is feasibility ranges. You can get this range from the condition. Okay, same as before, same as changes in the objective function coefficient. We can use the optimal tableau from the original LP to calculate these three things, okay, to find these three things. So refer to the TOEICO original model in example 4.1. So determination of dual price and feasibility range. Okay, recognizing that the dual price and their feasibility range are rooted in making changes in the right hand side of the constraints. The dual price, or also known as shadow price, for the ith constraint of LP is the amount by which the optimal Z value is improved. Increase in the maximization problem and decrease in the minimization problem. If the right hand side of the ith constraint is increased or decreased by 1 unit. Suppose that D1, D2 and D3 are the positive or negative changes made in the allotted daily manufacturing time of operations A, B and C respectively. Thus, the TOEICO model can then be changed to this new model. So the difference is only at the right hand side. As you can see here, we plus D1, D2 and D3 for each constraint. So we use capital letter for these changes on the right hand side. To express the optimum simplex tableau of the modified problem in terms of the changes D1, D2 and D3, we first rewrite the starting tableau using the new right hand side. Okay, so here as usual we move to the left hand side. So -3, -2, -5, 0, 0, 0. So 0 at the right hand side. So so the BV for this initial tableau, the first one should be S1, S2, S1, S2 and S3. Okay, so 1, 3, 1, 2, 0, 4, 2, 0, 4. Third column, 1, 2, 0, 1, 2, 0, and then 1, 0, 0, 0, 1, 0, 0, 0, 1. 430, 460, 420 for the right hand side. And then we have additional parameters. So for D1, the first one should be in the row 0, 0, 0, 0, because there's no D1, D2, D3 at the objective function. Okay, for the first constraint, we have 1 and 0, 0, 0, 1, 0, 0, 0, 1. Okay, so as you can see here, the two shaded area are identical. Hence, after a few of simplex iterations with same row operations as in the original model, the columns in the two highlighted areas will also be identical in the optimal tableaus as shown below. Because we do ERO row by row, right? Okay, so the optimal tableau should be, so here we have X2 as the BB, X3 and S3 here. Okay, so for D1, D2, D3 columns, we just copy S1, S2 and S3, which are the other PVs in the initial tableau here. So 1, 2, 0, 1 over 2, negative 1 over 4, 0, 0, 1 over 2, 0, negative 2, 1, 1. Okay. Okay, so the new optimum tableau provides the following optimal solution. From a row 0, we can see that Z equals to 1350, as you can see at right hand side column, plus D1 plus 2 D2. Okay, 1350 plus D1 plus 2 D2 for the first row Z. And then for first constraint, as you can see here, X2 equals to 100 plus 1 over 2 D1 minus 1 over 4 D2. Row 2, X3 equals to 230 plus 1 over 2 D2, and S3 equals to 20 minus 2 D1 plus D2 plus D3. Okay, so X3 230 plus 1 over 2 D2. S3 equals to 20 minus 2D1 plus D2 plus D3. So, row Z will give you the dual price. And row 1, 2 and 3 will provide us with feasibility range and also condition. Okay, this optimal solution can be used to determine the dual price and the feasibility range. Okay, so dual price, from this new objective function, this one, new objective function, Z equals to 1350 plus 1D1 plus 2D2 plus 0D3, right? Okay, actually the equation shows that a unit change in operation A, first constraint, capacity. So D1 equals to plus minus 1 minute, because this is in minutes, right? So it will change Z by Rm 1 ringgit. For second constraint, we look at the coefficient of D2. A unit change in operation B capacity change Z by Rm 2 ringgit. And the coefficient of D3 Rm0, a unit change in operation C capacity change Z by Rm0. Okay. So by definition, the corresponding dual price for operation A is Rm 1 ringgit, operation B Rm 2 ringgit, and operation C 0. Okay, so the higher the dual price, the better. Let's say if you have an additional worker, so it is best to put the worker at operation B, because every 1 minute change in the operation B, it will change Z by Rm 2 ringgit. Okay, so feasibility range, we can get from row 1, row 2, and row 3 from the optimal tableau. So from here, x2, x3, and s3, we know that all the variables are greater or equals to 0, meaning that x2 equals to 100 plus 1 over 2 d1 minus 1 over 4 d2 is also greater or equals to 0. x3 greater or equals to 0, so s3 also greater or equals to 0. So this is the feasibility condition. Okay. So simultaneous changes D1, D2, and D3 that satisfy these inequalities will keep the solution feasible. The new optimum solution can be found by substituting out the values of D1, D2, and D3. Okay, let's look at an example as in case 1. To illustrate the use of these conditions, suppose that the manufacturing time available for operations A, B, and C are 400, 448, and 430 minutes. So D1 is equals to 400 minus 430 equals to negative 30. And D2 equals to 448 minus 460 negative 12. And D3 430 minus 420, so equals to 10. So by substituting in the feasibility conditions, so we get x2 equals to 88, x3 equals to 230 plus 1 over 2 negative 12 equals to 224. So greater than 0. And S3, 20 minus plus negative 12 plus 10. So we get 78, which is also greater than 0. Therefore, feasible. Hence, the current basis remains feasible with the new optimal solution values. So, x2 equals to 88, x3 equals to 224, and s3 equals to 78. So by using these values, we can calculate the new value for z. So 3 multiplied by 0 plus 2 multiplied by 88 plus 5 multiplied by 224. So we get 1,296 as a new value for z. Or we can also use the dual price to calculate the new value for z. So 1,350 plus 1. So D1 equals to negative 30 plus, so 2 the dual price. So D2 equals to negative 12, okay, plus 0 the dual price for constraint 3 multiplied by D3, which is 10. Therefore, RM 1,296. So these feasibility conditions can be used to find the feasibility range associated with changes the right hand side one at a time. Okay, so next we find the feasibility range by using the feasibility conditions that we have obtained. Okay, so feasibility range for D1, a unit change in operation A for the first constraint. So D1 meaning that D2 equals to D3 equals to 0. Thus, x2 equals to 100 plus 1 over 2 D1 greater or equals to 0. So D1 greater or equals to negative 200. Okay, second condition for variable x3 equals to 230 greater or equals to 0, because in here there is no D1 in the second condition. Okay, so next condition, S3 equals to 20 minus 2 multiplied by D1 greater or equals to 0. Therefore, simplify this, we get D1 less than or equals to 10. Okay, so draw a real number line. Negative 200. Another one, D1 less than or equals to 10. So 10. Positive 10, okay. So the range is between these two values. So negative 200 less than or equals to D1 less than or equals to 10. Okay, next feasibility range for D2, a unit change in operation B or D2 means that D1 equals to D3 equals to 0. So X2 equals to 100 minus 1 over 4 D2 greater or equals to 0. Simplify, you get D2 less than or equals to 400. X3 230 plus 1 over 2 D2 greater or equals to 0. So D2 greater or equals to negative 400. Third BV, 20 plus D2 greater or equals to 0. So D2 greater or equals to negative 20. Real number line. Sorry, this one negative 460, right? 460. So negative 460. Then we have negative 20. And then 400. So the first inequality, D2 less than or equals to 400. So less than to the left. Okay, second, greater or equals to negative 460. Third, greater or equals to negative 20. So the range that satisfies all the conditions is in between these 2 points. So negative 20 less than or equals to D2 less than or equals to 400. Okay. Third feasibility range, a unit change in operation C, D3, means that D1 equals to D2 equals to 0. Okay, so for the first condition, is there any D3? There's no D3, right? The first condition doesn't have D3. Second condition also doesn't have D3. Only the third condition that has D3. So 20 plus D3 greater or equals to 0. You simplify this, you get D3 greater or equals to negative 20. So D3 greater or equals to negative 20. Okay. Next, the dual price and their feasibility range for the LP can be summarized as in the following table. So table 4.2. The dual price for the first constraint 1, second constraint 2, third constraint 0. And the feasibility range D1, D2, and D3. Okay, so D1 must be in between negative 200 then negative 20 less than or equals to D2 less than or equals to 400, and D3 greater or equals to negative 20. So here we have the original right hand side at column current. So 430 for the first right hand side, second right hand side 460, third right hand side 420. So according to this feasibility range, the change for this right hand side can be decreased by negative 200. So 430 minus 200, we get 230. And it can be increased by 10 units. So plus 10, you get 440. For this one, second right hand side, maximum value for this right hand side is 460 plus 400, so 860. And it can be decreased by 20 units, so 460 minus 20, we get 440. 420, it can be decreased by 20 units, so minus 20, we get 400. And there is no upper bound for this change, therefore here it can go up to infinity. Okay, so this is the second example where all three conditions are feasible. So you can calculate the new value for Z. Z is 1350 plus the change here. So here the change, D1 30, negative 12, and 100. So just substitute inside into this equation. So we get it should be equals to 1000. Don't forget the unit RM, 1356. Okay. Okay, let's look at second case where there is a infeasible condition. So in case 2, alternatively, if the changes in the right hand side are such that D1 equals to 50, D2 equals to negative 20, and D3 equals to negative 20, then X2 we get 100 plus 1 over 250 minus 1 over 4 negative 20, so X2 equals to 130, so feasible because greater than 0. For X3, 230 plus 1 over 2 negative 20, so here we get 220, also greater or equals to 0. S3, 20 minus 2 multiplied by 50 plus negative 2 plus negative 2. So here we get negative value. So negative 120, which is less than 0. Therefore, for this condition, it is infeasible. Infeasible since S3 less than 0, hence the current solution does not remain feasible. So for this case, further calculations will be needed to find the new solution by using the dual simplex method. Okay, so you need to use this type of conclusion if one of the condition is infeasible. Okay. We will learn how to solve this example 4.4 in the next subtopic, which is dual simplex method in example 4.6. So as for homework for this subtopic, you need to submit exercise 4.2.